We previously learned that there are two useful tools for explaining the periodic trends. They were effective nuclear charge and shielding. In the next few minutes, we're going to examine those two things, effective nuclear charge and shielding. Effective nuclear charge is a measure of the positive nuclear charge experienced by an electron. So in other words, if there's an electron, how much does that positive charge from the nucleus pull on the electron? So it's a measure of how much positive charge this electron experiences. You know that in the nucleus are protons. There's a positive charge here. So how much is that electron pulled towards the positive charge? That's what effective nuclear charge is. You probably guessed, the more positive the charge, the more pull this electron experiences. So let's take a look at what happens as we go left to right across the period. Let's take a look. You know number 3, 4, 5, 6, 7. That's the atomic number. And that tells us how many protons there are. So you can see the number increases. The number of protons going left to right across a period increases. That means the number of positive charges inside the nucleus increases. If there's more positive charges here, this electron will be pulled in tighter towards the nucleus. What about as we go down a group? Well, hydrogen has 1 proton, lithium has 3, sodium has 11, potassium has 19, 37, 55, 87. So you can see that going down a group, nuclear charge also increases. So as a summary, the relationship between atomic number and effective nuclear charge is direct. As atomic number increases, effective nuclear charge increases. Now let's take a look at shielding. Shielding, or the number of occupied energy levels. When we say occupied energy levels, we're talking about the number of energy levels that are occupied by electrons. And each occupied energy level is going to act as a shield. An atom's valence electrons are shielded from the nuclear charge by electrons in the inner energy levels. That is, each inner energy level acts as a shield. Okay, so this is the valence electron for this particular atom. Now you know that the positive nuclear charge pulls this electron in towards itself. So this electron experiences a positive nuclear charge. But in between this valence electron and this positive nucleus, there are 2 energy levels. These energy levels are occupied by electrons. And each of these 2 inner energy levels acts as a shield. And that reduces the strength of the pull that this electron experiences. So these 2 inner layers of electrons, they shield this valence electron from the pull of the nucleus. So let's take a look at what happens to shielding as we go left to right across the period. Remember that the period number, it's the same for all of these within the same period. So for example, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they're all in the second period. The valence electrons are all in the second period. So they have the same number of shields. It stays the same. However, as you go down a group, this is the first period, the second period, the third period, 4th, 5th, 6th, and 7th. Each time you go down a group, you add a new shield. So the number of shields increases as you go down a group. So we've looked at 2 things, effective nuclear charge and shielding. These 2 things will help us explain every trend that we're going to study. So be sure that you understand effective nuclear charge and shielding. We will use those two things to explain all of the trends. Going forward, we also need to keep in mind, when studying the periodic trends, shielding is more important than nuclear charge. We will of course consider both shielding and nuclear charge, but shielding will be more important.